A weak acid or a weak base is one that exists in equilibrium with water. To say that an acid or a base is weak has no relationship to how corrosive it is or how much damage it could do if you spill it. It just simply means that it is existing in equilibrium with water. Here's an example of a weak acid, HCN, with water. This exists in equilibrium. It is not a forward arrow reaction. It's an equilibrium reaction to produce cyanide and H3O+. And here's an example of a weak base with water in equilibrium producing ammonium and hydroxide. In the next few videos, we're going to be spending more time talking about weak acids and weak bases, the extent to which they react with water, and how we can use this information to calculate their pH and things like that. Before we move on, I do want to talk about a relationship between the strength of an acid or the strength of a base and the strength of its conjugate base or conjugate acid. So we're going to make kind of a little table type thing right here. If we have an acid that is strong or relatively strong, so this could literally mean that it's one of the 6 strong acids, or maybe it's a weak acid, but it's kind of strong, relatively speaking, among the weak acids. A strong or strong-ish acid will have a weak or a weaker, weak-ish conjugate base. And the strength of the acid is totally related to the weakness of its conjugate base. So if we have a truly strong, like completely, totally very strong acid, the conjugate base is just going to be extremely weak, just totally, totally weak. If we have a kind of strong acid, then we're going to have a kind of weak conjugate base. So we've got kind of 2 extreme scenarios here. If this is very, very strong, this will be very, very weak. If it's kind of strong, it's going to be kind of weak. And this is also true for bases. So if we have a really strong base or a strong-ish base, it is going to have a weak conjugate acid. And then we can say the same thing kind of for the opposite. So if we have a weak acid or a relatively weak acid, they are going to have a strong conjugate base or a strong-ish conjugate base. So we have this inverse relationship between the strength of an acid and its conjugate base or vice versa. And a weak base will have a strongish conjugate acid. So going back to this, weak base is going to have a strong-ish conjugate acid. If this is an extremely weak base, then this is going to be a really strong acid. If it's kind of a weak base, this will be a kind of a weak acid.